Hello, Assalamu alaikum. Our next topic in SPSS videos is the correlation. Correlation is the statistical association between the predictors and the test variable or dependent variable. This tool helps in getting statistical computations about three things: existence of association, weight of association, and direction of the association between predictors and the dependent variable or test variable. By existence, we mean that whether or not there is some kind of association between the predictors and the dependent variable. For example, if the R score is 0.46 or 0.25, these two show that there is association. However, 0.46 is greater than 0.25 and 0.25 is not acceptable in social sciences because as per experts, the minimum R score should be 0.3. So 0.46 is acceptable while 0.25 is not acceptable in terms of the existence of association. On 0.25, we shall declare that there is no association or association doesn't exist between the two variables. Strength of the link refers to the weight or to the power of the R score. For example, 0.72 is bigger than 0.4, so the power of 0.72 is higher than 0.4 or 0.4. Likewise, the R score also gives us information about whether the relationship or association is positive or negative. For example, if the result is 0.56 without any sign of plus minus, then it is positive relationship. But if the score comes with negative symbol like this, minus 0.61, then the direction of relationship is negative. Now let's go for testing and having a practical experience of how correlation analysis runs and how these results of the association can be achieved. We shall activate a data matrix to run the correlation analysis. The example we have used and discussed in the beginning of this video, that for example we have self-confidence as the predictor, organizational culture as the second predictor, and designation as the third predictor, while employee performance is the test variable or the dependent variable. To run the correlation, we click on Analyze and then select Correlate and Bivariate. In this pop-up window, we shall first put the predictors, self-confidence, organizational culture, and designation, and finally the test variable or the dependent variable of employee performance. The Pearson correlation option is already clicked, so we keep it as it is and go for getting the results. Here is the output of correlation analysis, the table which gives us all the information about the existence of association, weight of the association, as well as the direction of the association. In social sciences, the researcher is more interested in the association between the predictors and the test variable or the dependent variable. So we shall start checking whether self-confidence is associated with employee performance or not. In this coordinate, we can see that the R value of association between self-confidence and employee performance is 0.529, which is a huge R score. And more importantly, it is significant because the p-value is falling at 0.000, which is far less than the required threshold or critical value of 0.05. Further, organizational culture is also very strongly, very hugely associated with the employee performance, along with huge and powerful significance. The p-value is 0.000, while the r value is 0.7, greater than the self-confidence, but both are associated and positively associated. Third, designation as the predictor is also associated with employee performance. The R value is 0.414 with P value 0.000. So, initially it is proved that these three predictors are significantly associated with the test variable, onto which we shall use regression analysis to check the cause of these three variables on the effect to affect the employee performance. Further, we have to check the collinearity issue. Collinearity refers to the association or statistical association between the predictors themselves, self-confidence associated with organizational culture and designation. According to experts, if the collinearity figure is 0.7 or below, then it is acceptable, in the sense that it will not disturb the correlation results. However, as per experts, if the collinearity statistics is greater than 0.7, then the results can be questionable. In this case, we can see that self-confidence and organizational culture, they are associated, and the R value is 0.691. It is also significant. So luckily the R value is less than 7.7, therefore acceptable. Likewise, self-confidence and designation, they are not connected because their p-value is insignificant, 0.07, which is far greater than the required critical value of 0.05. So there is no significant association between self-confidence and the other predictor, designation. Further, the designation and the organizational culture, they are also associated, and the R value is 0.284, which is less than the acceptable value of 0.3 as per experts of statistical analysis. So we can conclude that there is no problem of collinearity showing the significant relationships between the predictors themselves. So our hypothesis that whether or not the predictors are significantly associated with the employee performance is accepted and substantiated, and we can proceed with our analysis beyond the correlations to the regression analysis. In our next video, we shall talk about the regression analysis. Hello, assalamu alaikum. Now we shall move forward from the correlation analysis to the regression analysis. In correlation analysis, our last video, we confirmed that whether there is significant relationship between all the predictors and the dependent variable. In our example, predictors included self-confidence, organizational culture, and designation of the employees in some organization, and the dependent variable is employee performance. Now, regression analysis is the procedure in SPSS which helps the researcher to measure statistics on the cause and effect connections between the predictors and the test or criterion variable. There are two forms or formats of regression analysis at the initial level. One is simple regression, when our model includes only one independent variable x and the dependent variable y. But if we use more than one predictors in a regression analysis, like in our case x1, x2 and x3, three independent variables and the dependent variable y. So simple regression and multiple regression are two basic procedures of regression analysis wherein we compute statistics about the cause and effect relations between the independent and dependent variable. Now let's go for computing statistical results of the cause and effect analysis. We shall begin with the analyze menu and then select regression procedure from the drop down window, and that this popping up window, and select linear regression. In this box we have the place for dependent variable and the independent variable. In simple regression we shall post dependent variable in this column and then the predictor in the independence column. But we are going to run multiple regression, therefore employee performance will go into the dependent variable and the three variables of self-confidence, organizational culture and designation of the employees, it will come in the box for independent variables. To have some more statistics, particularly for the collinearity problem in the regression analysis that we discussed in our last video. Collinearity is the problem in the sense that if there is higher correlation between the predictors, then the results are questionable. So for this purpose, different tests are used. For the time being, we shall use a simple test, Durbin-Watson test, which gives the statistics or score about the collinearity, and the standard is that the score should be close to 1. So we shall continue and press OK. Here are the results, the model summary. In model summary, we have to check this R square for understanding the change brought in the dependent variable because of the predictors. For example, here it is 0.551, which means that 55% of change in the dependent variable is explained by the predictor variables. Second is the ANOVA table and the coefficients table. We shall discuss this here. I have brought those three tables of model summary, ANOVA and coefficients for better visibility. So here you can see, to answer our research question, and the question is whether or not three predictors are bringing change variation in the dependent variable employee performance or not. So a lot of statistics comes out, but we have to use certain statistics like R square, which is called coefficient of determination, or simply it gives the statistics about how much change has occurred in the dependent variable because of the predictors, and in our case it is about 55%. Durbin-Watson test, as we have said, that it needs to be close to 1 as per experts. So our test gives us 1.3, which is close to 1 and accepted as showing there is no or not noticeable collinearity between the predictors. ANOVA table, which gives statistics about the F value and its significance, and if the F value is within the required range, it means that the model used for regression is FIT, and it really explains the variation in the dependent variable, successfully explains the change in the dependent variable because of the three predictors. Last, third table and the most critical important table onto which our decision will be based regarding the acceptance or rejection of the hypothesis. Coefficients table gives us statistics about each variable and its role in the regression process. For example, first predictor, it has significance value, which means it is playing the role. The p-value is 0.02, which is less than the required 0.05. Likewise, t-score is 2.32, which is far greater than the required threshold of 1.96. Likewise, its beta weight is 0.13. Organizational culture, second predictor, has bigger beta weight. It is the beta weight is the strength of the effect. It's the p-value of organizational culture is also within range less than 0.05. T-score is greater than 1.96. And the final third variable predictor, designation, also has beta weight, t-score greater than 1.96, and the p-value is also significant. Given these statistics, we shall decide that the hypothesis regarding the impact of three predictors on the dependent variable, which is also significant, is there, and it has been proved with the evidence from the statistical analysis of the related data. So that is all about simple regression analysis, and I hope that you must have got a bird's eye view or a simple understanding of what is regression and how it works through SPSS. See you in next video. Khuda Hafiz.